I'm going to talk to you about, I was thinking about what should be the title. And as a professor, I should have put something which is technological. But then I thought about it and I said, what do most senior people deal with? And it's often managing risks. You have multiple options and you don't know which one to pick. So what we're trying to do is manage risk. And how do we assess that? It's often based on our experience and experience of the people we trust. So I want to share with you a thought and some work that's been going on complex systems of systems. The world is a big place. You know, if you fly to Africa, you'll be amazed how big, for example, South Africa is. It's an enormous place. And we have people moving all around the world. This is the air transportation. This is day and night. During the day, number of flights that are flying around. You see the concentration around Europe. You see the concentration around North America and Far East Asia and India, and you see pretty sparse the rest. This basically represents people getting on a plane and traveling around. Business travelers for leisure. And then you look at how shipping, global trade, how we produce products and we send it around the world. There are a number of bottlenecks all around the world, from the area around the North Sea to the Persian Gulf, to the Gulf of Mexico, and around Cape Town, and clearly around China and Japan. You see these in Korea. You see these bottlenecks and transportation. This is an interconnected world. What often we do is we look at our own local case and we are not considering how does this interconnection take place. This is immigration from different countries to the other. I looked up the number of people that are moving as immigrants. And it's an amazing thing. Since the invent of turbofan engine, the number of immigrants has gone up by a factor of 5. But the world population have gone up by a factor of 1.6. So about 3 times more immigrants move around the world. And here you see sources and sinks where people are traveling. Roughly 3% of the world population is immigrants today. This is not, and 20, 30 years ago, 50 years ago, it was almost insignificant. What are the drivers of this complex world? Urbanization, people moving to cities, moving away from the agricultural base to cities, aging population in OECD, the rich countries, and growth in the least developed, driving immigration. We have global markets that are dealing with finance as though there are no borders, and then you have governments, each one wanting to control their finance and their own cash flow and their own tax base. We have geopolitical competition for resources and influence. And we have one of the most striking things, and all of us deal with this, is a societal transformation because of technological change. What is happening with our communication networks? What is happening to our young? I mean, I have my kids, just the attention spans are changing. How we process data, information, how we communicate. And then we have long-tail events like climate change, where it takes decades or centuries or millennia to impact to be fully absorbed. We deal with all of this, and we have dealt with it for some time. But what is different? I mean, if you look at A place like Pearl River Delta, within 20 years, tens of millions of people moved into, this is on the left, is 1990, green is agriculture, and within 20 years, I don't know if you have traveled there. When I traveled there, I was amazed at the amount of traffic and the lack of infrastructure. We build rapidly, and we don't know how everything interacts with each other. By 2050, it is estimated that 70% of the world population will be living in urban areas. Africa is growing rapidly, India, Far East Asia. The developing world, the population is remaining pretty much stagnant, but the rest is moving. And even in developed world, even you look at a country like Switzerland, what you find is when people move here, they move to the cities. The young people move, they don't move to the urban areas, to suburban areas. This has an impact on our infrastructure. Global warming is one of those facts. If you look at the basic physics of it, it's obvious that we should have global warming. It's just people cannot agree on the time scale of it. But it's going to change water distribution around the world. It's going to cause movement of people. Now, I don't know when that will happen, but it must happen. Just the basic physics of it will drive it. With all these changes, what would be the impact on energy, our infrastructure, our transportation systems? It's not driven by one country, it's not driven by one person, it's driven by how we change as humanity around the world. And the infrastructure is a key element that what we deal with. We provide the infrastructure that drives all of this. We did a study within Switzerland, and it was an amazing thing. We looked at who comes to Switzerland. This is immigration to Switzerland between the year 2000 and 2015. We were astounded to find out that 60% of immigrants are between the age of 20 and 39. And by the way, this applies in other parts of the world, maybe not to this extreme, but what you find is there is an age gap, 20 to 40, where people get up and move, and often they go to cities. In Europe, it's mainly from European Union that come to Switzerland. Now, I'm going to show you a thesis. Up to now, this happened. We reacted to it. Over the last 10 years, we've been looking at, can we use digital tools to bring some better insight into our planning process into the future? And how do we manage risk of development? To do that, rather than going along the path of set a plan, develop, observe, adjust, which has been the traditional way, is there a way we can shorten the time to tie it all together, such that you can fuse data, real-time data, as well as scenarios that could happen to plan as you move forward? This approach, together with combining with macroeconomic level, can help us, we think, develop better scenarios into the future, but we grow our database from bottom up. We are not making assumptions, we model everything from bottom up. So about 10 years ago, about 9 years ago, we started a program where we looked at a process where we generated 4 tracks. One is big data. How do we gather up information of what is happening around the world? What do we mean by data? That was the first question. People, buildings, cars, transportation system, economics, everything that we could find that goes down to fundamental base level of human being for a society. And then we wanted to know the big problem is often the boundary condition. Where do you draw the line? So instead of picking a city or a country, we decided to pick continents. So work on the level of a continent, gather up the data. It's a major effort to do that. Then we take the physical cause and effect models together to make analysis of what could happen, where we use our best engineering knowledge. One of the biggest challenges is figuring out the scenario, what could happen. And one of the goals of this conference is really to look at what could happen in the future. What if? And these are often political scenarios. These are not just you come up with. These are driven by global drivers. And then presented in a way that people can understand what is happening. Right now, our database covers North America, continental Europe, Far East Asia. Actually, it doesn't show Korea. Korea is also part of it. China, Korea, Japan, and Sub-Saharan Africa. We actually go down to a 30-meter by 30-meter scale. We use satellite image processing. We scrape the web, you name it. We gather data. If it is out there, we gather it up and we process it and put it all together. And when we cannot do that, we send people in the field to gather it up. These are all geo-referenced. Then we run simulations on an hourly basis for 30 years in advance. 1 year is 8,600 hours. 30 years is 250,000 time steps per hour. So we run 250,000 hours, and then we say, how will a solution evolve? And we run stochastic models, so we allow for noise to get enter the system. We run long-range weather models. We go continental scale from ocean to ocean. This is the European continent, and we calibrate and validate it versus all available data to make sure that we are fine. The weather data is coupled. For example, when we talk about energy, we know about rain, we know about sun, we know about the temperature, and that is used in our analysis. It's all an integrated system. We look at issues such as mobility of people. This is Switzerland. We model every human being. We have one agent per person. And that agent has age, sex, marital status, career, jobs. We simulate the life of the person, including transportation and traffic. We model the traffic every second, and then we aggregate. We have large-scale computing, massive computing of GPUs, so we can run large-scale scenarios. I'm going to show you results from this. I just want to show you that it's been 10 years in works, and a team of 15, 20 people that are working on it. It's scientifically what we're trying to do best we can do. We don't predict future, we just look at possible scenarios. Within that, we looked at a couple of cases. For example, we looked at the case of European energy infrastructure. This is every single power plant in Europe. There are 33,000 power plants. We model it hourly, and we ramp them up and down every 15 minutes or an hour. We run model TSO of every country, and we do market analysis between the two. We cycle the power plants and look at what should the cycling characteristic look like. Oh, by the way, there we have coal, lignite, natural gas, nuclear, hydro, biomass, wind, and solar. This is the transmission grid of Europe. It's 277,000 kilometers. We model the demand, sectoral demand, population demand, together with transmission and generation and the fuel supply. All added together, and we model the regulatory framework on top. The demand is implied by looking at hourly demand for the year, including seasonal variation, and is applied on a continental scale based on a population that is there. This demand includes population, commerce, industry, transport, and economics. We couple it to the gas supply. This is the gas network, as well as fuel supply, the coal network, all the way down to Russia, as well as LNG ports. We modeled those within our simulations. Here I show Nord Stream 2. This is a pipeline that Russia wants to build to come to Europe. Now, this one line has really a big impact on markets within Europe. And we wanted to know what happens if you build a pipeline or you don't. What happens to the energy mix in the future? This includes also the LNG plants, as I mentioned. We look at scenarios such as disruption of power. This is, we assume Russia turns off one pipeline through Poland. And then so what will happen? This includes, by the way, we model all the backup as well as storage devices. And this is the change in the gas pressure in different pipelines around the continental Europe with a cut of power from Russia. And the interesting thing is that the place that gets the most hit is northern Spain, followed by central Italy and northern Poland and Germany. Now, a pipeline being cut off in Russia, coming off from Belarus, coming through to Poland, will have a fundamental impact on the cities in northern Spain. They will run out of gas very quickly. It's how interconnected we are. We can actually, this is really one of the key things that we have to understand is we are all connected and you cannot assume that you can control everything. The other issues was, for example, when you have a policy of 45% renewable energy, how can we achieve that? The European Union wants to have all the electricity 45% by 2030. Can we achieve it economically? What will be the impact on gas power plants? Do we need more gas turbines? Or how about steam turbines? What kind? What size? What would be the CO2 pricing impact? What if Russians build Nord Stream 2 or not? And how would LNG import impact all of this altogether? Well, we actually looked at this and we ran a 30-year scenario of European Union. And we said, yeah, it can be done economically, relatively modestly in terms of the subsidies, and in some cases none. And we can tell you where you should build it. And by the way, we need about 600 billion in equity investment from insurance companies and pension funds to make it happen. So that can be done. So that's there, and mainly solar and wind. The next question was, what would CO2 taxation do? So we said, well, what kind of taxes do we use? So we ran different scenarios of different taxation level, 25 euro per ton, 50 euro per ton, or 100 euro per ton. And we looked at the difference between fuel switch, between gas and coal. And what you find is that it doesn't matter what the level, the higher the CO2 pricing, the more gas comes into play rather than coal, but the overall level is going to drop for European Union. So building a lot of gas turbines or steam turbines are not going to be happening in Europe. It will happen elsewhere. But the rate of it depends on government regulation. CO2 pricing, for example, and also ability to have flexible capacity to balance the grid. These are the type of scenarios that help us look at government policy, look at financial requirement to make it happen, and then say, do we have the right product? Do we have the right products to make that happen or not? But if you just make a product and hope that there would be a market, maybe there would, maybe there wouldn't. We need to look at longer range effects. One longer range effect is the LNG supply. We have a panel on oil and gas, And the question is, if we build more LNG plants around Europe, what would be the impact on security of supply and economics of LNG plants, the whole energy mix? What we find is the winners and losers actually happens to be different countries. We found, for example, Russia's supply to Germany will go up, but the big losers will be Poland and Czech Republic. But Spain and France actually do better with more LNG plants. So there are different actors, even within the same union, that have different incentives. So there is pull and push on LNG, liquefied natural gas, depending on who you are. So the decision to go with LNG will have regional impact, not just overall impact. It also comes down Nord Stream 2. This, in fact, has one of the biggest impacts on the energy mix in Europe, is if the Russian line from Russia to Germany is built, what we find is that will cause the biggest economic shift in the energy mix, and it will encourage more gas and it will lower the prices. Now, if you're an investor, you may not want lower energy prices, but this is one of the factors that will come into play. And finally, one last, we looked at electric cars, because we modeled the whole continent. We said, okay, what if we switch to electric cars? It turned out that using electric cars without the renewable backup, renewable generation will cause much more pollution because it starts firing the lignite plants. The brown is the lignite plants. And what we find is that the power to charge the electric cars will be mainly in Europe supplied by lignite plants, which are actually more polluting than gasoline in a car. So the way to go around it is first to convert to renewable before you charge to electric, because otherwise within Europe the lignite plants will dominate. So that's a continental scale. If you go further to a country scale, we looked at Korean Peninsula. We said, what will be the shifts that are happening in Korea? So this is another case study. In this case study, we looked at actually both North and South Korea, power plants, transmission grid, fuel supply, population, including movement of population. 83 terawatt of power plants that are modeled. And we cycled it, and we took the new government policy by 2029, and we said, what could happen? What would be the shift, given the government policy shift? And what would be the investment requirement? And interestingly, what you find is the new government policy there will shift towards much more coal. Coal usage will go up. Gas usage will go up, natural gas, but it will cause more coal demand by the new targets that, in terms of the part load capacity. I'm sorry, the base load will go down, but the part load capacity, the coal and the gas turbine, but the coal part load has to go up. So if I'm a manufacturer of steam turbines, I need to be able to cycle, and I have to be able to cycle them up and down relatively fast if I want to sell in Korea. Because if I just have base load, that's not going to work. So looking at the government policy, looking at the demand that is there, helps us develop boundary condition, how to develop our machines for future. A last example that I'm going to just use before I end is more now on a city scale. So I started on a continent, on a country, now a city. We are working together with city of St. Gallen, where we are looking at it's a small utility that manages the utility of St. Gallen. We wanted to work with them on saying how do they transition the energy need in the future, particularly come up with business models for electric cars. This is one of the things that they are very interested in doing. It's a city you see Zurich there and you see St. Gallen, 39,000 people coming in, 23,000 people internally, so it's a relatively small city. And one of the issues was, where would you put electric chargers and how would you compensate for the investment required for that? This is the type of questions that many small utilities are dealing with for themselves. How do we go further in the future? Well, to do that, we actually had to model, this is a traffic and people movement around the city. It's in a valley. And what we found was the charging pattern and the driving pattern of people will mean that there is really no business in selling electricity during the day. It's very difficult to make a business case out of it. So the charging model for electric cars have to be different. It cannot be on selling electricity. You will never make it up. So you have to come up with a more innovative business model. And that will have an impact on the energy demand, electricity demand, that then they have to fulfill. Now, what I've tried to do in these 3 cases, and I go to my last slide, the demands in future that we are dealing with, we often don't know what we want to do. Companies and academia, we make assumptions of what is needed, and we try to do the best we can on that. We can change that paradigm by using data. And we have a panel on digitalization, and digitalization is going to have a first-order effect. But if we focus it on people movement and urbanization, be it in transport or in energy, we will come up with various scenarios that will provide boundary conditions for product developments. We are an interconnected world, and what we find really the biggest driver is policy. People say regulation. Regulation comes after policy. You start with policy, the political will to change something. Then you have regulation. Then you have business and finance. And then you have technology and products. But the source of it is policy. We have to consider, understand. We don't have to become all politicians, but we need to understand the political and policy framework that decisions are made, such that our technical decisions are valid. Data and how human brain absorbs data is the biggest challenge we have. It's not actually running computation. That's actually not that difficult. We've been doing it for years. One of our biggest challenges is how do we understand the data that we generate, particularly in a very complex system. We are working on that, but this is an area that is evolving. And the future product development, you cannot just create one product for one, say we sell to everybody. You have to consider regional variations. And this is, I know I'm preaching to the choir, but this is an important fact. Now, to lead to the next talk, I'm going to say, as engineers, often we dismiss finance. And finance often dismiss technologies. The reality is we are interconnected, but finance has a particular role. They are an assessor of risk-reward ratio. If you ask what is the role of financial sector, is to come independently, look at the project and say, is the risk-reward ratio justifies the investment or not? And if the answer is yes, you move forward. And one of the people that does that is Chris Manser here, who's going to talk to us next. So with that, I want to thank you for your attention. And if you have, I'm not going to take questions from me. If you have any questions from me, please see me during the breaks. But I thank you for your attention, and I look forward to a good conference for everybody here. Thank you.